Hello, student, and welcome for the session. In this session, we will discuss about the design of spur gear. Okay, so basically, we have already discussed the basic theory related to the spur gear. Now we are concentrating or moving towards the design. Okay, so I will share a single page. Okay, now look at this a single tooth. Okay, so based on the design, first of all we need to understand what type of loads acting on a tooth. So when we consider a single tooth, there is a it seems like a cantilever beam. Okay, it is approximately seen like a cantilever beam. So this we can design by using beam strength. So what is meant by beam strength? The beam strength of the gear tooth is the maximum tangential load. That is the maximum tangential load the gear tooth can be with the gear tooth can be take without tooth breakage. Okay, so this much load, that is it is shown over here, that is in a form of pt. Okay, so that is a tangential load which can be taken by the tooth. Okay, so the design is normally based on the few assumptions. So based on the beam strength, there are five assumptions which is to be noted over here. First one, we have considered the full load is acting at the tip of single tooth. तो जो पूरा लोड है वो टूथ के टिप पे concentrate हो रहा है. That is we are considering first assumption. Second, the effect of radial force is neglected. Then third, load is uniformly distributed across the full face width. Then the effect of the stress concentration is get neglected, and the frictional forces due to the tooth slides are neglected. When we consider the full load is acting at the tip of the tooth, this is a conservative assumption because the full load is never acting at the tip of the single tooth. When the contact is at the tip, the load is being shared by more than one pair, and the load is taken by the single pair. Only when the contact point moves down some distance from the tip. So when it engages, more than one tooth actually engages. So it's an assumption. Then for second assumption, the effect of the radial force is neglected. The radial force which induce the direct compressive stresses, and it is relatively very small. In addition to this, the radial force induced additional compressive stresses at the point where it is connected. It relieves the part of tensile stress at another point, which is more significant, and hence we are assuming the total surface having maximum radial force, and we are neglecting the maximum tangential force, and we are neglecting the radial force. Third one, the load is uniformly distributed across the full face. You can see in figure number 17.39. This is possible only if the gear, shaft, and bearing are properly aligned. Then accurately manufactured and perfectly assembled. If this occurs only be if you are doing appropriate assembly. If there is any backlash, any misalignment, then this phenomena will not be occur. So there is a single one-sided pressure is applied, and tooth get what you can say, the total pressure will not be distributed to full area. Fourth one, the effect of the stress concentration is neglected. The stress concentration factor were unknown in Levis time. To identify, to design the equation, we are going for with the Levis equation of beam string. Then the frictional force, which is the effect of the frictional force on the tooth bending, is insignificant, so we are neglecting that. Okay, so these are the few 5 points based on the, or you can say, assumptions for Lewis equation, or you can say beam strength equation. Okay, so we need to identify the actual stresses. You can look at here, only tangential and radial forces are generally apply over the tooth. Okay, and out of that we are neglecting the radial forces, and we are considering it is purely tensile, or you can say tensile. But when we consider the appropriate arrangement, then it is look like a cantilever beam. Okay, so the maximum bending stress you can see over here, the maximum bending stress we can find out. Okay, so here, refer this equation. Okay, refer this equation, very important equation. So this is called as a bending endurance strength, or you can say the equation where the maximum tensile stress has been calculated based on the bending stress. Okay, in this equation, the capital Y is called as a Levis form factor. The capital Y is provide a Levis form factor. Now, this is very important to find out the Lewis form factor, because uh, by using the Lewis form factor, you can calculate the information like uh, it gives the relationship between the tangential force and corresponding bending stress. Okay. Also, this kind of factor is provide the strength of the material, strength of the material. If if we have to choose that, if there are two, when we said a pair में क्या होता है, एक पिनियन होता है, एक गियर होता है. तो पिनियन और गियर में आपका कौन सा वीकर है, ये अगर आपको फाइंड आउट करना है, तो that you need to identify based on this Lewis form factor. Okay, so how we can find out? By multiplying y into sigma b, y into sigma b, ये आपको फाइंड आउट करना है बेस्ड ऑन ईच मटेरियल. तो इससे आपको क्या मिल जाएगा, उसका स्ट्रेंथ, बेंडिंग स्ट्रेंथ मिल जाएगा. तो हर मटेरियल का स्ट्रेंथ अलग होता है. सो बेस्ड ऑन दिस यू कैन गेट the a value. Okay, and you can compare the value for both pinion and gear, and you can find out the actual value, that which one is weaker. Okay, you can just look at here. It is observed that, and sorry, by using the product of sigma b into y decides the weaker between pinion and gear. Okay, the Lewis form factor is less for pinion as compared to the gear when the same material is used for pinion and gear. Okay, and always consider pinion is the weaker element. Okay, in the pair of pinion and gear. Okay, so Lewis form factor is generally depend upon three factors: number of teeth, then tooth system, and the point of application of the load. Okay, so based on these 3 points, we need to find out the actual value of Lewis form factor. Okay, um, we will refer a design data book for full design of the spur gear. Okay, just we are discussing about the basic theory, that beam strength theory and Lewis form factor, how it affects in a design. Okay, now I'm switching my page to the PhD design data book. So just take a glance of the PhD design data book, which process, how the procedure can be used to for design that we will discuss. Okay. You can refer PhD page number 1.14 for the different materials which is normally used in a gear design. ओके आप यहाँ पे देख सकते हैं उसका डेजिग्नेशन है और उसके मटेरियल कॉम्बिनेशंस है. सो दिस इज द नथिंग बट alloy steel which we are preferring for manufacturing the gear. Next one, the actual PhD pages started for gear design, Spur, helical, and Buell is 8.1. Okay, so these are the few standard nomenclatures which we need to be used commonly for all design. A is the center distance, R the cone radius, I is the gear ratio. Gear ratio is depend upon the number of teeth and gear divided by pinion or the speed of wheel, or you can say gear and the speed divided by speed of pinion. तो इससे आपको gear ratio पता चलेगा, and gear ratio is very important for design. Z are number nothing but the number of teeth. Z1 number of teeth on pinion and Z2 the number of teeth on wheel. M is the modulus, a module. Uh, Based on the module, we are design all the parameters of the gear, which we have discussed in the last lecture. B is the phase width, then alpha is the pressure angle, beta is the helix angle, which we'll discuss in a helical gear design. Okay, there is a psi. Psi is nothing but the ratio of B divided by A, and psi m is the nothing but the ratio of B divided by M. Psi y is the ratio of R divided by B. Y is the called as a form factor. YV is called as an equivalent a form factor based on the equivalent number of teeth in a virtual cylinder. This form factor we are considering in helical gear design and bevel gear design. Okay, MT is the torque transmitted by pinion. Okay, and E is the equivalent Young modulus. Okay, let's see how it is mentioned. Okay, so first one, PhD page number 8.2. PhD page number 8.2 gives the idea about the basic load factors. What are the different factors which need to be considered and how we can calculate. Load concentration factor we can find out from table number 14. Okay, so similarly we can find out. Now here is the important location. In table number 1, the recommended series of models are given. Okay, when we design any gear, initially we calculate the module, and we need to identify what should be the preferable standard for module. Okay, अगर हम लोगों ने मॉड्यूल कैलकुलेट किया 3.15, तो 3.15 अवेलेबल है क्या स्टैंडर्ड में, that should be identified. Okay, and if it is not there, you can choose the next standard. तो अगर 3.25 नहीं है तो मैं 4 मॉडल चूज कर सकता हूँ या फिर प्रेफर्ड सीरीज से 3.5 चूज कर सकता हूँ. सो बेस्ड ऑन दिस स्टैंडर्ड्स अवेलेबल यू कैन चूज the model dimension. In PhD page number 8.4, there is a materials which is allotted for particular gear, pinion and wheel based on the gear ratio, or you can say transmission ratio. If the transmission ratio is lesser than 8, you can prefer just a minute. Okay, if the gear ratio is lesser than the 8, you can refer for this one. If gear ratio is lesser than the 4, you can refer second one, and if the gear ratio is lesser than greater than the 4, you can refer this column, this row. Okay, so in this manner you can refer the materials. Okay, but you need to one more you need to understood, you can use only these size column wise combinations. You could not be use this and this as a combination. Okay, go with the column wise only. Now, what are the standard gear ratio? The gear ratios are given here, but we are preferring that when we go for design of spur, we are referring that maximum transmission ratio is transfer is up to the 4. Okay, 4 तक ही ट्रांसमिशन स्टैंडर्ड ट्रांसमिशन रेशियो स्पर गियर के लिए अलाउ कर सकते हो. if 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 अगर ट्रांसमिशन रेशियो मोर देन 8 रहेगा तो क्या करना पड़ेगा? अगर मोर देन 8 है तो आपको मल्टी स्टेज के लिए प्रेफरेबल करना पड़ेगा, क्योंकि maximum transmission ratio which is allotted for spur and helical is 8, but we are not going till the 8. Okay, we are preferred it is up to the 6 or 4, maximum 4, जो सफर साइड में सबसे बेस्ट है. तो अगर ज्यादा है वैल्यू, अगर ट्रांसमिशन रेशियो का ज्यादा है तो क्या करना पड़ेगा? सो फॉर दैट पर्पज यू गो फॉर मल्टी स्टेज. you go for multi-stage. A simple example of that, अगर आपके पास ट्रांसमिशन रेशियो 16 है, 1/6, तो 1/6 इज इट नॉट पॉसिबल फॉर सिंगल स्टेज ऑफ स्पर और हेलिकल. तो उसके लिए you can make a square root of 16, square root of 16, so you will get a value which can be divided into the two stage transmission. तो इसका मतलब क्या है? आप अगर जब स्क्वायर रूट लेते हो तो इसका मतलब है कि आप पूरा ट्रांसमिशन 2 स्टेज में डिवाइड कर रहे हो. अगर आप क्यूब रूट लेते हो तो आप 3 स्टेज में डिवाइड कर रहे हो. तो सिमिलर वे आपको फाइंड आउट करना पड़ेगा कि ईच स्टेज में कितना ट्रांसमिशन रेशो होना चाहिए. So that's why when you take a square root of 16, you get value of 4. तो पहले जो ट्रांसमिशन रेशियो आएगा पहले स्टेज का वो आएगा 4, दूसरे का भी आएगा 4. So 4 4 16. Okay, so in a similar fashion you can find out the values of transmission ratio for each stage. Okay, तो आप ऐसे find out कर सकते हो. Now refer PSG page number 8.13, which is very important for us. So here table number 8. Okay, you can refer this table number 8 for a design purpose. Okay, how? Because here you can look at the equation 2.1. Okay, in 2.1 the equation is given m is greater than or equal to 1.26 cube root of design torque divided by y design sigma b psi m into z. Okay, so these parameters are known with us because we have seen this parameter in first page. ओके तो आपको ये पता है कि ये चीजें क्या है. अभी इसको फाइंड आउट कैसे करना है. So we will discuss this total procedure in a design. So nutshell, you need to first of all find out the module. ओके तो स्पर में पहला स्टेज है, आपको पहले मॉड्यूल डिजाइन करना है. बट व्हाट बेसिस, कौन सा लोड लेना है यहाँ पे? इट इज टोटली बेस्ड ऑन दी बीम स्ट्रेंथ क्राइटेरिया. ओके तो जो फॉर्मूला बेस्ड ऑन द बीम स्ट्रेंथ है, based on that beam strength criteria you need to find out the module in through equation number 2.1. After the finding the module, you can put that value in equation number 2.5 and calculate the actual bending stress which is induced. Okay, and it should not be exceeded than the design bending stress. Okay, ये ज्यादा नहीं होना चाहिए, कम होना चाहिए. So अगर आपका ये कम होता है then आपका डिजाइन सेफ है. आफ्टर दिस फर्स्ट 2 steps और rather than say a single step, क्योंकि हमने तो बीम स्ट्रेंथ से और बेंडिंग स्ट्रेंथ से डिजाइन किया, उसको चेक किया. नाउ नेक्स्ट वन we need to again check for contact stresses. You can say a VS stress or you can say a surface strength. ठीक है, ये स्ट्रेंथ क्यों चेक करना है? बिकॉज इट इज पॉसिबल दैट the module which is sustain the bending stress, but it can be fail into the wear. ओके, तो ये वियर में भी फेल हो सकता है, तो हमें वो चेक करना पड़ेगा क्या ये वियर में फेल हो रहा है कि नहीं हो रहा है. ओके, फॉर दैट you can refer equation number 1.1. So based on the values you identify the value of a. अभी a का वैल्यू ऑफ इंपेरिकल रिलेशन से भी निकाल सकते हो. ओके, दैट वी विल डिस्कस इट फर्दर. तो a का वैल्यू आप पहले ही निकाल के ले लो. ओके, एंड यू जस्ट चेक वेदर दैट वैल्यू इज मैचेस और नॉट. If it is lesser than the calculated, then what is, if it is greater than calculated, if what. Okay, so that we need to identify. अगर वो वैल्यू अगर आपके यहाँ पे मिलता है तो आपको वो फाइंड आउट करना पड़ेगा कि ये बराबर है कि नहीं. So for that we can directly go for checking. We can directly go for checking because we have all the dimensions, we have all the parameters. We will just check the crushing stress or sigma c which should be lesser than the design one. अगर ऐसा होता है तो हमारा जो डिजाइन है वो सेफ है. अगर नहीं हो रहा है then you need to be changed in a module. Okay, so next one, the table number 9 which is related to Young's modulus. तो मटेरियल का जो भी Young's modulus है उसके इक्वेशंस के उसके वैल्यूज यहाँ पे दिए हैं and the criteria is also given. Table number 10 is the type of transmission. It is nothing but the value of psi, which is nothing but the equation of B by A, or it is totally depend upon the way the gearbox is mounted, or can say open type of gearing. Open type of gearing है तो इसका रेशो इसका जो रेंज है वो 0.1 से लेके 0.3 तक है. अगर आप स्पीड रेड्यूसर यूज कर रहे हो, फॉर एग्जांपल अ क्लोज गियर बॉक्स अगर यूज कर रहे हो, सो फॉर दैट देयर आर वेरियस velocity ratios are there. So for low velocity it is up to the 1. It is if the velocity get increased, the value of the psi is get decreased. Okay, you can look at over here. Now if you are using gearbox with the sliding gears, then the range is given to 0.12 to 0.15. Okay, generally we can took to the one, or if you are designed for low speed में ज्यादा टॉर्क रहता है तो लो स्पीड में आप डिजाइन करोगे तो आपको ज्यादा वैल्यू मिल जाएगा. if it is changes, if it is changes, then the value of B get changed. Then recommended value for psi which is already given. Okay, then similarly for psi m based on the transmission, grounded gears and non-grounded gears, the equation values gear. Generally for design we took the value is equal to 10. We took the value is equal to 10. So B is equal to 10m. ये हम लोग generally consider करते हैं. Now table number 13, the y psi y is given. Okay, similarly you can find out. Now the important point. Okay, so calculating the designed load, how we can calculate. आपको अगर 6 किलोवाट पावर दिया है तो आप उसको ट्रांसफर करना है, या फिर आपको इक्वेशन में 3000 न्यूटन 300 और 3 न्यूटन मीटर आपको पावर ट्रांसमिशन करना है, तो उसको एज इट इज ट्रांसफर करोगे? नो, we need to add some factors that is called as a, normally we can say service factor, then it's a safety factor. Why it is necessary? If we are designed based on the actual value, then what happen, whatever the dimension we get, that can survive that actual value, but due to the temperature or environmental condition or any magnetic field, because of that uncertainty criteria, the values are the properties of material get varied, and because of that it can be lose that their strength. तो हमने अगर 3000 न्यूटन के लिए कोई मटेरियल या फिर कोई डायमेंशन डिजाइन किया है और वहां पे थर्मल स्ट्रेसेस बढ़ रहे हैं, तो वो क्या करेगा, अपना स्ट्रेंथ लूज करेगा. अगर 3000 के लिए डिजाइन किया, मे बी इट कैन बी फेल फॉर 2500. Okay, so to avoid these consequences we need to design for more. Okay, तो इसके लिए हम लोग ज्यादा लोड कंसिडर करेंगे. Okay, if initially assume is a symmetric scheme, then you can multiply with 1.3. If it is unsymmetric overhanging, then go for multiplication with the 1.5. KDK, it's nothing but dynamic load factor and the nominal power transmission factor. Okay, you can look at over. If MT is given in the form of kilowatt and power HP, then you can directly use this equation to transfer, or you can convert them. Next one is the load carrying factors, which is necessary to calculate the above things. Okay, dynamic load factor, then surface design factor. Okay, for different material, the factors are given. Then the equivalent mean life. Okay, important is a form factor. Okay, we can directly calculate or based on the number of tooth, you can find out the value. Okay, then bending stress. How we can calculate the bending stress is a formula is given over here. Then selection of factor of safety. The factor of safety is depend upon the material. Okay, again उसमें भी heat treatment है, tempered है, उसके basis पे again उसको changes किया है. Then stress concentration factor, like for bending. Okay, so next PhD page number 8.22. Okay, where in table number 26 we have some empirical relation. Okay, तो ये empirical relation क्या देंगे, अगर आपने मॉड्यूल फाइंड आउट किया है तो आपको remaining values को remaining parameters you can find out. For example, if you calculated module, then it is a m, then value of a you can find out, that is the center distance, you can find out from this equation. Then height correction factor, bottom clearance, you can find out from this equation. Tooth depth, you can find out with this empirical relation. Pitch diameter, you can find out over here. Pitch diameter is nothing but the multiplication of module into the number of tooth. Okay, tip diameter. Okay, so these are the empirical relation for the other dimensions, and you can find out if you are calculated the module. So basic agenda to design is design a model. So based on the model you can find out the different equations. Now next one, we have done everything in a static manner. Then why we needed to find out the stresses in dynamic load also, because it is important that to the design in a dynamic load condition also, because in a dynamic load condition the actual variation will be faced by the material. Okay, तो उसके लिए हम लोग डायनामिक लोडिंग कंडीशन भी लेते हैं. Now in the dynamic loading condition, we are using Levis and Buckingham's equation. So Levis, we already discussed with the Levis form factor. In preliminary stages of the gear design, we should extremely difficult to calculate the dynamic load. So that after the calculating the module, we can able to find out the important things like pitch circle diameter. Okay, so these things we can calculate, and after that we are able to find out the other parameters like CV, velocity factor. Okay, then different loads. Because of equation, Levis equation, you can find out the static load. Okay, you can find out the static load. अभी static load के लिए equation कौन सा है? You can refer this equation. Page number 8.50. F is equal to sigma b dash y pe. Okay, you can find out the all the values. Then you can find out the tensile load and the dynamic load. Okay, this is a Lewis form factor equation. We can refer and find out the value of small y, or you can choose from the standard table which is I previously shown to you. Now next we need to find out the um, value of CV based on the different velocity application. Okay, for that you should know the velocity. Then go for FW. Okay, अभी यहाँ पे दो चीजें हैं. फर्स्ट देयर आर टू कंडीशंस. फर्स्ट कंडीशन क्या है कि आपका Fs का वैल्यू दैट इज a static load should be greater than that of the dynamic load. This is the first condition. And second condition, the wear load should be greater than the dynamic load. अगर ये दो कंडीशन सेटिस्फाई होती है तो ही आपका डिजाइन सेफ है. ओके, अदरवाइज यू नीड टू चेंज. अभी चेंज करना पड़ेगा तो क्या करेंगे चेंज? यू शुड टू चेंज द वैल्यू ऑफ मॉड्यूल. आप मॉड्यूल को चेंज करो या फिर मटेरियल चेंज करो. देयर इज टू वेरिएंट. Based on that you can go for variation. Okay, this is a equation. Based on that you can find out the dynamic bunking dynamic load. Okay, now this is a proportional diagram of spur gear, or you can say spur helical, both are same, only this angular helix angle will be there. So refer for the spur gear. After the completion of design you need to draw a schematic diagram such like this, and you have to list out few standard dimensions which using by empirical relation. Okay, so based on the empirical relation you should find out the different dimension. Okay, I hope you have understood the basic procedure, how we can going for a design, what are the different aspects of the design. Then these pages I have already shared with you, or you can refer in a chat box where I can put the link of this design PhD data book. Okay, you can take refer and download so that you can get the whole data with you. Okay, because in full design we are referring only these pages. Okay, thank you very much.